Hello mathematicians, this is Mr. Mailhot. Let's do some math. We're going to keep looking at parallel and perpendicular lines, and today in your packet we're going to do some summary notes, some examples to get these ideas a little bit more filled out. You can see how the title should be set up, creating parallel and perpendicular lines, and two ideas that we're going to look at. Let me zoom out real quick, and remember you can pause whenever you need to rewind and see how it should be set up, but I just want you to see what we're going to do today. We're going to do 4 examples, and that's it, okay? So go ahead and pause when you need to get your page set up like this, and then come back when you're ready, all right? Okay, I hope you got it set up. Before we get started, I want to show you something cool on Desmos. I just threw up some equations in here that are parallel and perpendicular. All the red ones are parallel lines. They all have the same slope of 2. And all the blue ones are parallel to each other. They have a slope of -1/2, you see. But the blues and the reds are perpendicular to each other. The opposite reciprocal of 2 is -1/2, and vice versa. The opposite reciprocal of -1/2 is 2. What I want to draw your attention to, though, is where the y-intercepts are. You see how even though they might have the same slope or opposite reciprocal slopes, what's different about them is where they cross the y-axis. Some cross at 4, or 3, or 0, or you can see this one here would cross at -6. Let's go find it. That's way down here at -6, right? Now, when we do these problems today, the slopes may be the same or opposite reciprocals, but the y-intercepts are going to be different. All right? So let's get started. What we know from last time, and what you guys have gotten some practice with, is that parallel lines have the same slopes, the exact same. And perpendicular lines have opposite reciprocal slopes. Remember, opposite means if it's positive, it becomes negative, and vice versa. All right? And reciprocal just means it's flipped upside down. The slope is inverted or flipped around the fraction. Okay? With that, let's do an example. Example 1, write the equation of the line that passes through the point -2, 7 and is parallel to the line y equals -4x plus 1. Well, since they're parallel, that means the slope is going to be -4. So when we write the equation y equals mx plus b, we're not going to have a plus 1 at the end, because it's going to be a different y-intercept, but the slope will be the same. Now, how do we go about finding the equation? Well, look at the point that you were given, -2, 7. That's an x, and that's a y. So in our equation, just like we did with your balloon bungees, plug in the x and the y into the equation. For the y, we're going to put 7, and the slope is -4, times -2, because that's the x value. I'll do a little color coding. You can pause and do color coding if you'd like. Sometimes that's helpful. Now, we don't know the y-intercept or the b, so we're going to leave it as plus b. Now we just got to do the math. Multiplying -4 and 2, or -4 and -2, that's 8 plus b. Subtract 8 on both sides, and we get, oh, that one's not canceling, this one is. We get b equals -1. So our equation is going to be y equals -4x minus 1. Different equation, but parallel, because they have the same slope. Let's do another example. Example 2. Same idea. Write an equation that passes through a point, 3, -1, and it's parallel to that line. Well, this one's not in y equals mx plus b form, so let's make it into y equals mx plus b form. You know what? I'm actually going to pause the video, see if you can finish this one out on your own. Not the whole problem, but just put it into slope-intercept form. Go. Okay, mathematicians, we're back. You should have got this equation here. Y equals 1/3 x minus 3. Remember, when you divide here, negative divided by negative is positive, and there's a 1 in front of that x. That's where the 1/3 comes from. Let's do the same process as we did on the other side. We're going to use the same slope for y equals mx plus b. We're going to use the same slope as the one that this equation that's given to us has of 1/3. Oh, but we're not going to have minus 3. We're going to have plus b. Let's take the x and the y and plug them in for x and y. So for the y, we're going to put -1. For the y, we're going to put -1. And for the x, we're going to put 3. So in here, we're going to put 3 plus b, because that's what we're solving for. All right, let's finish it out. -1 equals, well, let's see, 1/3 times 3. That's one you could do in your head. That's just 1. But if you need a little help, remember you can always make this a fraction, multiply straight across. We'd have 3 over 3, which is just 1 plus b. Subtract 1 on both sides, and we end up with b equaling -2. So our new equation, because we're going to put this b in for b right here, our new equation is y equals 1/3 x, because it's parallel, same slope, minus 2. Same slope, different y-intercept. All right? Let's go on to example 3. Example 3. Remember, you guys, you can pause at any time, rewatch, do what you need to do. Example 3. Write the equation of the line that passes through the point 4, 3 and is perpendicular to the line y equals 2x minus 4. Well, perpendicular means if this slope is 2, then the slope we need has to be the opposite reciprocal of that, -1/2. So in our equation, y equals mx plus b, we're going to have a slope of -1/2 x plus b. The same idea works here. This is our x, this is our y. Plug them into the equation. Plug in the 3 where the y goes. -1/2 times 4 plus b. Now half of 4 is 2, but if we have a negative sign, that's going to give us -2 plus b. Add 2 to both sides to solve for b, and I'm seeing b is going to equal 5. So our new equation, where we're going to put this b value of 5 in for here, is going to be y equals -1/2 x plus 5. Different y-intercept and opposite reciprocal slope of the one that we were given. All right, last example, y'all. Here we go. Number 4. Look at how it's kind of set up as before. Write the equation of the line that passes through the point -5, 1 and is perpendicular to the line 5x plus 3y equals -1, or -21. First step, convert this into slope-intercept form. Convert this into slope-intercept form. I'm going to pause the video. You do it. See if you get it right. Pause. All right, mathematicians, we're back. You should have got this equation, y equals -5/3 x minus 7, which means the slope that we need for a perpendicular line is going to be the opposite, so positive, reciprocal 3/5. So in our equation, y equals mx plus b, we're going to use the slope, y equals 3/5 x plus b. Hey, if my video cuts out because I'm almost out of time, check the PDF for the final answer, okay? But let's keep going. We're going to plug in the x for the x and the y for the y.